We're going to figure out how to find the probability of at least one. I'm going to be combining two rules together. One is the multiplication rule, the other one is the complement. Use that to find the answer to this. Let's say we're giving you this quiz. This is a quiz I'm going to give you right now. Question number 1. What you see there is your quiz. This is the question. Just like that. And it has 4 answers. A, B, C, and D. Question number 2 has 3 answers. A, B, and C. Question number 3 has true and false for an answer. And question number 4, trying to make it, 4 answers? A, B, C, and D. Let's take that quiz. So write the 4 answers you think the correct answer. We'll see how many of you actually got 1 right, 2 right, 3 right, 4 right. Because when you have a test like this, how many possible outcomes to that test? There are 5 possible outcomes to this test. And the 5 possible outcomes will define X as the number of correct answers. And this is the probability of X. Is it possible to get 0 on this quiz?
Yes.
0 correct answers? Yes. Is it possible to get 1 correct answer? Yes. 2, yes. 3, yes. And 4. Those are all possible outcomes. So let's see this class, the way we did it. Did you have your answers yet written down?
Yeah.
Here's the correct answers. Question number 1, D. Number 2, A. Number 3, T. Number 4, B. How many of you got 0? 2 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10, 20%. 2 out of 10 got 0. How many people got 1 correct answer? 1, 2, 3, 4. 4 out of 10 got 1 correct answer. 3 correct answers. Oh, 2 correct answers. Yes, I forgot the 2. Sorry. 2. We got 3. And 3 correct answers. 1. And 4 correct answers? 0. If you find that's a 0.2, that's a 0.4, that's a 0.3, that's a 0.1, that's a 0. When you add all these numbers, what's the sum? What do you think? 1. It has to be 1. Anytime you cover all the possibility, your sum here should be 1. Actually, that's one way. This table, well, you'll get to that next chapter. It's called probability distribution table. 2 things when you look at a table like this to see if that table is valid or not. Does the sum add up to 1? That's the first one. And the second one, is the probability of each one of these, is it between 0 and 1? Because the probability will never be below 0, will never be more than 1. So when you look at these numbers, are they between 0 and 1? Yes, that seems like a valid table. So let's see really mathematically, what is your chance from this experiment? That's a small class of 10 people. Well, but what's your chance of getting a 0 on the test? This one says 20%. Let's see what the real number should be for a question or a test like this. Well, to get a 0 on this test, that means what?
There's a 3/4 chance on the first question, 2/3 chance on the second.
Okay. So what you're telling me, Scott, that means you got the question number 1, question number 2, question number 3, question number 4. To get 0 on that test, that means question number 1 was wrong, question number 2 was wrong, question number 3 was wrong, question number 4 was wrong. What Scott was saying, your chance of getting the wrong answer on question number 1, there are 3, assuming there's only one correct answer. There are 3 wrong answers out of how many? 4. So for question 1, 3 out of 4 times. Because it's and. You got to get this one wrong, and that one wrong, and this one. And always multiplication in statistics, or always addition. Question number 2. To get that question wrong, how many wrong answers on that question? 2 out of 3. Question number 3. 1 out of 2 is wrong. And question number 4 is what? 3 out of 4. Try to simplify the math. Gone. It says what? Your chance is 3 out of 16. So what was, let's see what 3 out of 16 on my calculator is. Clear everything. 3 divided by 16 equals 3 over 16. Very good. Menu. Number. Oh, what does it? Go back.
0.19.
What was it?
0.19.
Yeah.
3 divided by 16.
Yeah. What was the divided by 16? 18.7%. What did we get here? 20%. Small class, not bad. So we have 3 out of 16 chance of getting a 0 on that test. According to the math, you have a 19% chance. We got 20% because mathematically for this class you can never get 19. Because why? We have 10 students. Each one is a 10%. Now, this is the first scenario, getting 0 correct. Now let's look at 1 correct, and this is more challenging now. Here's question 1, question 2, question 3, question 4. To get 1 correct, it could happen if what? If the first one is correct and the other 3 are wrong. That's one way. Now when I said how many of you got 1 correct, there's 4 people. Did anyone get the first one right, the rest of them wrong? None of you. Did any of you got the first one wrong, the second one right, the third one wrong, and the fourth one wrong? The 4 people who got 1 correct answer. Nobody got that? Did any of you got the first one wrong, the second one wrong, the third one correct, the fourth one wrong? Yep. All 4 of you. And the other possibility could happen if it's wrong, correct. So there's 4 different ways you can get 1 correct answer. Not just one way. So you have to find the probability of each one of them, because could be this, or means add, could be this way, or could be that way, or could be this way. Well, let's look at that. For the first question to be correct, there's the test here. 1 out of 4 for the first one. The second one wrong, 2 out of 3. The third one wrong, 1 choice out of 2 is wrong. And the last one to get wrong there's 3 of them out of how many? 4. You know what? Let's not simplify it. We'll simplify later. That's 6 over what? 4 to 8. Is that 13? I mean, what am I saying? 13. 4 times 2 is 8. 96 is it? Okay, let's leave it over 96. Another way of getting 1 correct answer could be this scenario, which means the first one is wrong. First one's wrong is what? 3 out of 4. Second one is correct. That's 1 out of 3 choices. Third question is wrong. 1 out of 2. The last one is wrong, 3 out of 4. That's 9 out of 96. The other possibility, the first one is wrong, 3 out of 4. The second one is wrong. There's 2 out of 3 answers are wrong. Third one is correct, 1 out of 2, and the last one is wrong, 3 out of 4. 3 times 2, 6. 6 times 3, 18 out of 96. And for the last one, it says the first one was wrong. Three answers out of 4 were wrong. Second one is wrong. 2 out of 3 were wrong. Third one is wrong. 1 out of 2 is wrong. And the last one is correct. Only 1 out of 4. That's 6 over 96. When you add them, 6 and 9, 15. 15 plus 18. Is it 23? 23 plus 6. Did I say 23?
34.
6 and 9. 15. 15, 18. 33, not 23. 33. 33 plus 6 is what? 39 out of 36. 96, not 36. Notice both of these numbers you can divide by 3 if you want to simplify them. By 3, that's what? 13 over. By 3, this is, I should have left them in terms of 96. You know what? I'm going to leave them in terms of 96. Now I'll change that in terms of 96. In terms of 96, this number, 3 times 3, which is what? 9. 9 times 2, or 27. 3 times 27 times 2 is 50. Oh, I'm counting the wrong one here. 3 times 2 is 6 times 3, that's 18. So for this is really 18 out of 96. I don't want to simplify it. Too much math. Actually, there's a reason, because I'm trying to add them at the end and show you that the sum will be a 1. Yep. So it's 18 out of 96, which you can see is almost 19%. This one, 39 over 96. And if you do 39 out of 96, what's that number?
40.6%.
40.6, and what did we get? 40. Now let's see number 2. 2 correct answers. This is going to be longer for 2 correct answers.
Isn't there more?
Yep, more choices. Here's question 1, question 2, question 3, question 4. You go correct, correct, wrong, wrong. Correct, wrong, correct, wrong. Or correct, wrong, wrong, correct. Or wrong, correct, correct, wrong. Or wrong, correct, wrong, correct. Or wrong, wrong, correct, correct. If you're really nervous about how am I going to be able to list all of these, that's actually not that difficult. What do? You make a tree. For the first questions, you have how many outcomes? 2, either correct or wrong. If you get the first question correct, when you guess on the second one is what? Correct or wrong. And if you get the first one is wrong, for the second question it's still going to be correct and wrong. For the third question is going to be what? Correct and wrong. And for the last question is what? Correct, wrong, correct, wrong, correct, wrong, correct, wrong, correct, wrong. That's all the possibilities. So one choice could be correct, 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 correct. Correct, 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 wrong. Correct, correct, wrong, correct. Correct, correct, wrong, wrong. You can list them all. correct, wrong, correct, 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 wrong, correct, wrong. Correct, wrong, wrong, correct. Correct, wrong, wrong, wrong. And you do the other half. So you can list all the different combinations that exist. That's one way of doing it. It's called the tree diagram. And when you look, you can group them, the ones with 1C in them, the one with 0C, the one with 3C, the one with 4C, and so forth. Now you look at this, and again, let's put that sheet back here, the questions. There's the questions. Can you still see them? Yes.
Does that mean there's 16
Correct.
outcomes?
Not 16, 2 to the power 4. Is that 16? 2 to the 4? Yes, 16. Yep. Because each question has how many? 2 choices. And you got how many questions? 4. So 2 times 2 times 2 times 2, 2 to the 4, which is 16. So imagine if the test has more choices. Imagine if you have 10 questions. 1,024 of them. You better hope in that case that every question has the same answers, like 4 answers. And because if they're all 4 answers, then these numbers, once you find one, the rest of them will be the same, just figuring out how many values. Then go, okay, whatever that number, multiplied by this. So now let's look at this. For the first one to be correct, it's what, 1 out of 4? As I said, I made it bad intentionally. The second one is correct, 1 out of 3. Next one is wrong, 1 out of 2 choices wrong. And the last one is wrong, which is what? 3 out of 4. That's 3 out of 96, if you don't simplify it. Let's look at the second one. Correct, the first question correct, 1 out of 4. Second one is wrong. Wrong is what? 2 out of 3 choices wrong. Third one is correct, 1 out of 2. The last one is, was it wrong? 3 out of 4. 6 out of 96. First one is correct, 1 out of 4. Second one is wrong, 2 out of 3. Third one is wrong, 1 out of 2. The last one is correct, 1 out of 4. 2 over 96. First one is wrong, 3 out of 4. Second one is correct, 1 out of 3. Third one is correct, 1 out of 2. The last one is wrong. Is that 3 out of 4? 9 out of 96. 2 more. We're making progress. Here we go. First one is wrong. Second one is correct. 1 out of 3. Next one is wrong. 1 out of 2. The last one is correct. 1 out of 4. 3 out of 96. Then the last one. The first one is wrong. 3 out of 4. Second one is wrong. 2 out of 3. Next one is correct, 1 out of 2. Last one is correct, 1 out of 4. 6 out of 96. And let's add all these numbers. 3 and 6, 9. 11, 20. 20 and 23, 29. So 29 out of 96. So, huh?
That wasn't all the possibilities.
No? Did I leave anything out?
Isn't there 16?
Oh, no, we still have 3 correct answers. That's, we just did the one. There's 16 for all of them. All of them is 16. There's only one case for 0 correct. Remember, there's only one? One case for the 0 correct. There's 4 cases for 1 correct. There are 6 cases for, 2 correct. When we go to 3 correct, it's going to be 4 more. And for 4 correct, it's going to be only 1 case. So when you look at them so far, this is 1 plus 4, that's 5, plus 6 of them, we're up to 11. Now let's find out what is 3 correct. Three correct, here we go. Question 1, question 2, question 3, question 4. Correct, 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 wrong. Correct, correct, wrong, correct. Correct, wrong, correct, correct, wrong, correct, correct, correct. There's 4 of them. So we had 11 cases covered so far, plus 4, that will make it what? 15. There's one more for the 4 correct. For the 4 correct, there's only one case. Correct, 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 correct. That's where the 16 different sets actually come in. So let's see what the probability of this one. Here we go. So for this one, we're saying correct. It's only 1 out of how many? 4 for the first question. Second one, 1 out of 3 choices is correct. 1 out of 2 choices is correct. And wrong answer is what? 3 out of 4. 3 out of 96. Correct, correct, wrong, correct. Correct is 1 out of 4. 1 out of 3. Wrong is what? 1 out of 2. Correct, 1 out of 4. 1 out of 96. Most of you got this one correct. Was it this one or this one? I can't remember which one. Correct was 1 out of 4. Wrong was what? 2 out of 3. Correct, 1 out of 2. And the last one correct, which is, or the third one correct, or the fourth one is correct, which is what? 1 out of 4. And the last one, the first one is wrong. That's 3 out of 4. Correct, 1 out of 3. Correct, 1 out of 2. Correct, 1 out of 4. 3 out of 96. And let's add them. 3 and 2. And by the way, I forgot, yeah, we'll finish that. 3 and 2, which is what? 5. Isn't that 9? 9 out of 96. What percent is that? Remember what percent? Is that 10% roughly? Remember when I asked you how many of you got 3 correct?
9.4.
9.4. How many of you got 3 correct? We had one person, which is what? 10%? When I said how many of you got 2 correct? 3 out of 10, which is what? 30%. What's that number? What, 30%?
Yeah, 30.2.
Yep. So we're right on the money. Because it's a small class, you can't get the 0.2, but we were right on the money. That's what's supposed to happen if you do it randomly. When we say you can't read the question, that means really random, because you have no idea what the question is. But if you know what the question is, you can eliminate 1 or 2, now your chances changes. Now the last one, 4 correct, forget it. 4 correct. For the first one's correct is what? 1 out of 4? The second one, yep, 1 out of 3. This is 1 out of 2. 1 out of 4. 1 out of 96, which is 1%. And we got what? 0. And that's, we got 0 for this. Nobody got 4 correct. This is 1%. So your chance of getting 100 on that test by guessing on it, forget it. Might as well go play the Powerball. Well, it's that bad. But it's 1 out of 96. And if you add all these numbers, they add up to a 1. So when we ask you what's the probability of at least 1, that means you got to go through the table and find how many different ways you can have 1 correct answer, like we did here. And find that answer. Then find how many different ways can you get 2 correct answers. List them all. And find that answer. Then go to the third page and find how many ways you can get 3 correct answers and 4 correct answers. Well, that's really silly to do that. Why? Because you know the sum is what? 1. Why not take 1 minus that number? So the probability of at least 1, you see it in a lot of math books, is 1 minus the probability of none. Scott, go ahead.
No, nothing.
Was that the point you're trying to make? Yep. So it's 1 minus the probability of none. So instead of figuring the answer for 1, 2, 3, 4 and kill yourself, find the chance for none and go 1 minus that number. I saw yesterday an article. It says the probability of having a car crash. There we go. The probability of having a car crash is 0.045, which is 4.5%. Someone to crash their car. Okay. Trent, how many people in your family? How many cars?
3.
3 cars? So Trent, they have 3 cars. That's per year here. What's the probability, I hope nothing happened to you, Trent, or your family, at least 1 car will crash, based on the number. So to find that answer, we're going to go, it's 1 minus the probability of none of them will crash. So that means Trent is not going to crash the car, Mom is not going to crash the car, Dad is not going to crash the car. This and that one. So what's the chance of that happening? None. So for Trent not to crash his car, he has a chance of what? 0.9. Is it 55? 1 minus that number.
Yes. Yeah.
Because if there's a 4.5% chance he'll crash, there's a 95.5% chance he will not crash the car. Times 0.955 times 0.955. We're assuming they are independent. Now, if Trent's dad was a horrible driver and he was the one teaching Trent how to drive, then that becomes dependent. It's probably going to increase the chance of that. But assuming they are independent, the probability of none crashing their car, there we go, 0.955 to the power of 3. 0.955 to the power 3 equals 0.87? 871 roughly. So what is the probability that at least 1 car will crash?
1 minus 1.
Yep. 1 minus 0.871. 12.9 is it? 0.129. Or there's a 12.9% chance there'll be 1 car crash. If you have 4 cars, that number will be a little bit higher. Why? Because when you multiply that number by 0.99955, that number will be a little bit smaller. So 1 minus smaller number becomes a bigger number. So the more cars that you have, if you have a family of 10 kids, you have 12 cars there. 0.955 to the power of 12. Ooh, almost went flying there. If I did 0.955 to the power of 12, it's 0.57. So you take 1 minus that number, 1 minus, let me move the mouse there. Come on, mouse. Becomes 42% chance. 0.955 to the power 12. I said there's 12 cars.
people.
Yeah, if there's 12 cars, as if the family has 12 cars, there's 10 kids in the family, each one has a car, mom and dad have a car, you have 12 cars, then your chance becomes at least one car crash among 12 cars is going to be much higher than if you only have one car or two cars.
Is it cars or drivers?
Well, if it's a driver, usually should be a driver, because the car, if you're not driving that car, you're only driving really one, even if you have two cars, you know? So it depends how you drive it. But again, it could be like one is a race car driver, which is your chance now is higher. So we'll just pretend simple.
Yeah, I think if you're a race car driver, you're probably a better driver than most people.
Except on the track. Except on the track. Yep. Another example where this is used, actually, I'll give you an idea, and it saves really a lot of money for the government. If we're going to do testing, let's say, for example, what is that, the new virus now, the mosquito one, Zika? Zika, the Zika disease, or HIV, the Zika, HIV, whatever the case is. Let's say we want to test, we'll do HIV testing. That's the vial blood. We take a blood from somebody, we test them. Well, there's a couple of problems with that testing. Let's say we're going to do a massive testing. We know the HIV virus is higher in Africa than here. So let's say the person is tested positive in Africa is, I don't know, 0.15, 15% you being positive tested for HIV. So that's HIV testing. So to test negative, the result is 1 minus 0.15, and you come out 0.85. Let's assume a few things. Assume, just to make the story more fun, we want to test 1 million people. And let's also assume at a rate of $100 they charge, the insurance company or the lab charges $100 per person, per tube. So if each one goes to the lab and have their blood tested, it will cost the country how much? 100 times a million people. It will cost them $100 million to test them. That's one of the problems. First, it's a lot of money. Second problem, how long is it going to take the lab to do that? You got to test 1 million tube.
A lot.
You know? 15% is really high. Let's go 5%. 15% is high. It could be, I don't know. I'm not really sure what the numbers there. So let's go 5%. That means the other number is what? 9.5? Now, 100 million, long time to test them. Here's the third problem. What are you going to do with these tubes now when you're done with them? 1 million tube. Throw them in a dumpster? Where? So we're going to take care of that too. A lot of issues. So now what will happen when we test them like this? We might take blood from 4 people and put them in one vial. 4 people. Could be 3, 4, but let's say I decide to go with 4 because the number is lower. I made it. So there's the first person. This is the second person blood. This is the third person's blood. By the way, this is how it's done on large scale. And this is the fourth person blood. We mix them all in one tube and we test them. This tube will come out positive if at least one of these people is positive. So we'll be positive if at least one of them is positive. So let's see. Since we're putting 4 people into one vial instead of testing 100 or 1 million tubes, so what's 1 million divided by 4? 250,000 tubes we have to test. The price, 250 times $100 per tube, is that what, 25 million? That's the initial test. So we test all of them by putting 4 people into one tube. So we tested how many of them? 250,000 tubes. The next question, what is the chance now that tube will be positive? Because if that tube comes out positive, guess what? I got to test every one of these people separate. If it comes out negative, all 4 of them pass. So if this comes out positive, I got to test every single person in that group there. So what's the chance that tube will be positive? To be positive, at least one is positive. So the tube will be positive. That means at least one is positive. And for one to be positive, that means I'll do that by 1 minus the probability of none. What's the chance that tube, it's not positive, it's negative? That means the first person was negative, and the second person was negative, and the third person was negative, and the fourth person was negative. So what's that chance?
0.95 to the 4.
0.95 to the power of 4. The first one's negative, the second one's negative, the third one's negative, and the fourth one is negative. Let's do the math.
Well, 81.5%.
0.85. More numbers?
Oh. 81.
81? 0.81.
45.
45. Okay, that's good. So that's the chance the tube is positive. One minus that number, is that the 0.8145 or just that number?
That number. Oh,
You do 1 minus.
sorry.
Go ahead. Yep.
Sorry. 1 minus is 0.1854.
Okay. Everyone get that number? 0.18. So it's an 18% chance. Well, we have what? 250,000 tube. They have 18% chance of being positive. So how many will come back positive? Let's see. Come back positive. Is going to be 250,000 of them times 0.1854.
Um, 46,000.
46,000?
373.
373 tubes will come out positive. Now, once they come out positive, what are you going to do now? You got to test each one of those people. Each one has blood for how many people in it? 4. So you take that number, you multiply it by 4, and that will tell me the number of people I need to test again. That doesn't mean they're all positive, but I need to go back and retest these people. So what's 46 times 374 times 4? 225 something?
It's 185,400.
200.
100.
4 times 4 is 16. Yep, you're right. So 185,000.
493.
493. Okay. So I need to test that many people. That's how many more tubes I need to test. At $100 a person, So the cost for that will be what? $18,549,300. So how much going to cost me altogether to test all these people? The 25 million plus the 18 million and some change. We're looking at what?
44 million?
43,549,000, right? $43,549,300 versus what? 100 million. We saved what? $57 million. The other thing we saved, instead of testing 1 million tubes, how many tubes are we testing? 250,000 plus 185.
Yeah.
About 450 something. 400 maybe in 35,000 tubes we testing versus 1 million tube. Less time in the lab, less stuff in the dump. But we took advantage of the probability of at least one. Yes?
If you put more in a tube.
Well, it depends on the percentage. It depends on that percentage. If that percentage is high, if you put more, that number becomes really high, so you're almost testing everyone. So there is a number actually cut off. You can do the math on that based on the percentage. What is the ultimate number? You do the math like this and you figure out, should I do 3, 4, 5, 6? If that number is really small, you can put 7 of them, you're still going to save money. But if that number is 15, 20%, and you put 4 of them, almost every tube comes out positive. Most of them. So you end up not saving any money.
What about on the second run? Why not put 2 in each tube?
You could. You could. I don't know if it'll save you that's more or not, but you could. You can try that and see mathematically what that number might be. Again, with low percentage, you can get rid of a lot of stuff, but as the percentage increase, it's tough to mix them. But you could the second time try 2 at a time instead of 1, and if it comes out positive, let's go back and test them.
So that is like, that's a common practice
Yep.
though?
Yep.
I don't even know.
Yep. When you're doing large amount.
Yeah.
They're not going to do that if you and I go and test our blood. The doctor says, go test your blood. They're not going to wait for mine and yours to test and put them together. But if we're doing massive testing, they'll try to figure out based on the percentage what's the ultimate number to use and do that. You know. We use the probability of not A. That's what we're using the complement, really. 1 minus that number. Like if you're traveling too and you're nervous about, am I going to wake up, Is the phone going to ring? You can get color alarm clock and use them there and use that. If the alarm clock has a 90% chance of being correct, you go have a job interview coming up and I really want to get that job. You don't want to be late going to that interview. And if your phone says sometimes it doesn't ring all the time, sometimes I don't hear it, there's a 90% chance it will work, but there's a 10% chance it doesn't work, what do? You take 3, 4 alarms, you put them in that room. One of them is going to go off eventually. So the chance becomes, instead of 90%, to almost 99. We also do that in testing, meaning what? Sometimes if you want to test CDs, a company will say, okay, we're going to test these CDs. Microsoft might come out with a new operating system, and they're going to ship this box out. This box has 1,000 CDs in it of the new operating system. Microsoft, our product is really good. The company that makes the CD for us, could be them, could be somebody else. We have a defective rate, probability of defective rate is 0.005, 0.5%. So that's really 0.5%. Our product is good, but there's always a chance as a CD is not good. They're not going to test every single CD when that rate is that low there. So what they do, they might have a policy that says, okay, we're going to take this box, we're going to select 10 of them from the box. If at least 1 CD failed, the box doesn't go out. So they're going to select 10 CDs from this box at random. If any CD is defective, the box doesn't go. The box stays home. Actually gets crushed and recycled and used again. We don't ship it. That might be their policy. We're going to select 10 CDs. And if they pass, so what's the chance a box like this will pass the test? Now, when you select these 10 CDs, you're not putting them back in the box. But remember we said last class, if you have a large sample, 1,000 is a large sample, and you're selecting a sample that's less than 5%, what's 5% of 1,000? Is 50? Is 10 less than 50? You can treat them as independent. You finished it?
Yeah.
Okay. So let's find out. So if at least one CD is defective, that box is not going out. So what's the chance this box will not go out? Of at least one. One defect, I said. That's right.
4.8%.
I don't know. It could be. It's 1 minus the probability of none.
So
1 minus, and listen, the boxes, so we're going to select one, the CD is not defective. So if it has that chance to be defective, what's the chance the CD is good?
0.995.
Good is 0.995. So for the CD to be not defective has a chance of 0.995. And you're selecting how many of them? 10. So 1 minus 0.995 to the power of 10. 1 minus 0.995 to the power of 10. Enter. Oh, I screwed up here. Delete, delete. To the power of 10. Somehow the power didn't go. Enter. 0.04889. You have almost a 5% chance that box will not be shipped. 4.8%. They don't test every one of them. They go, if somebody gets a bad CD, they can contact us. We'll apologize to them, give it to them free, whatever it is. Then we'll ship them another one, you know.
What's the probability that there isn't a defective CD in the rest of the box?
Well, you got to look at the whole box. That means the first one is good, the second one is good, the third one is good, the first one. You're saying all of them good?
All of the test ones are good. What's the percentage that one of the other 95% of the box isn't bad?
So would you have to like?
The other 99 will be 990. None of them are bad, right? Is that what you're saying? That means you have 990 all good. So since each one is good, 0.995, and how many of them there is? To the power of 995. You know. Remember, we expect to see 5 bad in this box.
Oh, 5%.
Yep. So there are going to be some bad ones there in the box. We expect to see at least 5 of them bad in the box there. You know.
0.7% chance.
The other thing we need to just mention while we are at it here, I'm almost done, is conditional probability. I mentioned that before. That's the probability of B given, knowing what A is. And that's defined as the probability of A and B divided by the probability of the given, which is A. We talked about that last time, right? Let's take this example. Drug testing. We're going to have positive drug test I heard a commercial yesterday. This company is looking for, I forgot how many people who can do machinist work. But one of the conditions, they have to be subject to drug testing at least once a month. And the other one, negative drug test. The problem with these tests we use, even if you're innocent, a lot of times these test result gives you the wrong value. Let's say here, subject, we know that person uses drug. He told us. "44 of them came out positive." We call that true positive. The person uses drug, the test says, yes, you do use drug. That's a true positive. 6 people, the test came out negative. They used drug, but the test came out negative. That's known as what? False negative. Because they are users, the test came out. So this is false negative. The first one we said true positive. True positive. Now, subject does not use drug. Not use drugs. And came out positive. 90 of them came out positive. We know the person doesn't use drug, but the test came out, yes, you do. That's false positive. And 860 of them came out negative, which is what? A true negative, because the person doesn't use it. So the test failed twice. It failed right here. People who use drug, the test says no, it's 6 of them, false negative. And it failed here. On 90 people, people do not use drug, and the test says yes, you do. So there's 96 of them here failed. If we add how many people took that test, this is the total number here. That's a 50. And what's this one? 950. When you add them, that's 1,000 people took that test. Negative 866. Positive, was it what? 134, is it? That's the total number. So the question, what's the probability the person uses drug? Given knowing the person tested positive. If you want to follow their equation, you say, oh, that's easy. We'll do it this way. The person uses drugs and tested positive. Divided by whatever that given one, which is what? The probability the person tested positive. So uses drugs and tested positive. Here we go. Person uses drugs and tested positive is how many? 44 out of what?
134.
Well, as of now, out of 1,000. I'm just saying, what's the chance the person uses drugs and tested positive? How many of these 1,000 people use drugs and tested positive? 44. Divided by tested positive. How many people tested positive out of the 1,000? So it's 134 out of 1,000. So what happens to 1,000? Mathematically, that will disappear. You end up with 44 over 134. Now, if you don't want to do the math here, there's an easier way to get to the answer. You know you are in this group. You tested positive. Just go, I'm right here. How many people tested positive altogether? 134. Out of those 134, how many were using drugs? That's where the answer, 44 over 134. So if you don't want to use that equation here, because that's the equation they gave us, you can just look at the chart. You got 134 people tested positive. Out of those, 44 used drug, and that's the answer. And if I want to do the next one, I can ask another question. How many people tested negative? Tested negative and not uses drug. Given did not use drug. Well, how many people did not use drug? Altogether, how many people did not use drug? 950. Out of the 950, how many of them tested negative? 860 out of the 950. And you can simplify the math. 86 over 95. If that was your answer, maybe you wouldn't want to simplify that or divide them, but that's how you can look at it. How many people here not use drug, not using drug here? All of these, the 950 of them did not use drugs. Out of those 950, 860 of them came out with negative test result. 860 out of 950. Okay, we'll stop here. We have one more section of the chapter. We'll finish it next time. Then we'll start thinking about the second test.